Hi, today I'm going to introduce you to CARLA, an open source simulation for autonomous driving research and development. CARLA is developed at the Center for Computer Vision at the Autonomous University of Barcelona. You can find details about the CARLA project at www.carla.org, and the documentation is hosted on Read the Docs. CARLA is a driving simulator aimed at generating training data and providing a testing environment for autonomous vehicles. It's based on the Unreal Engine, and it simulates physics and renders models of real-world environments and vehicles. The simulator uses the OpenDrive standard to define road networks, and it also provides an API in both C++ and Python to control the simulation. Also, numerous third-party applications used in autonomous driving and robotics can integrate directly with CARLA. The third-party applications that integrate with CARLA include ROS, the robotic operating system, and numerous physics and vehicle simulators including Sumo, CarSim, Scenic, and PTV VisSim. CARLA users can also create their own OpenDrive format road networks using the Roadrunner application. The system utilizes a client-server architecture, with the simulator running as a server application that accepts instructions from client processes, normally running Python code, written using the CARLA API. The server can connect with multiple clients, so the simulator can be controlled by a vehicle or physics simulation while simultaneously connecting with your autonomous vehicle machine learning stack to facilitate your training and testing. Today I'm going to show you how to get started with the CARLA simulator and its Python API. I'll show you how to set up the simulator, include some vehicles, and then control them with the traffic manager, then record some training data using a virtual camera. Before you get started, please refer to the CARLA Read the Docs site for installation instructions, install the simulator, and then make sure that it's working. You should also install Jupyter to follow the tutorial in notebook format. We highly recommend installing Jupyter Lab. So first things first, let's start up the simulator in a command terminal. So in Linux, you'll be running the shell script, and in Windows, you'll be running the .exe file. Once the simulator is up and running, start a Jupyter notebook and open that in a web browser so that you can edit it. The first thing we want to do when we start CARLA is make sure that the CARLA library is installed. So you can install it using pip on the command line or inside your Jupyter notebook. You may already have it installed if you followed the full installation procedure. Next thing, we need to import some libraries. So we want to import the CARLA library, and we may also want some utility functions from the time, random, and math libraries. After the imports, we want to then connect the client to the server, and we do this using CARLA's client object. The client object requires two arguments. So the first is the IP address of the machine where you're running the CARLA server. So in some cases, that might be your local machine, in which case you can put localhost. In other cases, if it's a network machine, then you need to put the full IP address on the network of that machine. The second argument is the port on which the CARLA server is running. So by default, this is 2000, but you can choose that when you launch CARLA on the command line. Next thing we need to create is the world object. So the world object has methods that allow us to access everything within the simulation. So we can access vehicles, buildings, pedestrians, and other things in the map like trees and traffic lights. It also allows us to add or spawn these objects as well. Next thing we want is the blueprint library. So the blueprint library gives us access to all the blueprints which you need to create objects within CARLA. And that includes vehicles, props, things like boxes or kiosks or things you might find in the street, and also pedestrians. So we can use the blueprint library to browse what we want to add and then use those blueprints to create things within our simulation. Next, we also need some spawn points. So in order to spawn a vehicle in the simulation, you need a 3D location where you want to put it. Each map in CARLA provides a set of spawn points which are set in sensible locations on the road so that you can spawn your vehicles on the road pointing in the right direction. So now that we've got our blueprint library and our spawn points, now we'll create a vehicle. So the first thing we want to do is find the vehicle blueprint from the blueprint library I'm specifying a specific vehicle which I want to use, Lincoln MKZ. So I'll find the blueprint for that vehicle, and then I will use the world objects try spawn actor method to spawn that vehicle. It's important that we use a try method here, because when you spawn vehicles within the simulation, it's not always necessarily going to work. For example, if you try and spawn a vehicle in a location which is already occupied by another vehicle or another object, the spawn will actually fail. Therefore, we need to use a try method to make sure that we catch when the spawning operation fails. Now that we've run that code to spawn the vehicle, we can see that there's not really any visible change, but that's probably because our vehicle is hiding behind a building somewhere. So to find it, we can use the spectator. So the spectator is basically the camera that you can see in the window on the left. You can actually move around and fly it through the city using the WASD keys and the mouse. But we can also access the spectator through the Python API and move it to a specific location. So in this case, I'm going to move it to a specific location, which is going to take us just above and behind the car that we've just spawned. So if we run this code, it will move the spectator to sit right behind the vehicle that we just spawned so that we can see it. So you can see it now in the window on the left. The spectator is an important part of the CARLA workflow. You can use it to inspect the simulation, fly around your town or city, and make sure that everything is working as you would expect. So now we've got the simulation up and running, and we also have our main vehicle in place. We want to add some more vehicles to the simulation. So in order to do that, I'm going to randomly select vehicles from the blueprint library. So we can use the random choice function to do that. And also remember to filter the blueprint library for vehicles. We don't want to spawn any other types of actors. And we will randomly choose from the spawn points to spawn all those extra vehicles. So now we can see, once we've run that code, that there are now other vehicles in the simulation next to the main vehicle. So the next thing we want to do is set all our vehicles in motion. So we can do that using CARLA's traffic manager. So the set autopilot function is a method of every single actor, and that will basically hand over control of each vehicle to the traffic manager, and they will move around the city, mimicking the behavior of real vehicles. So now that we've added some vehicles to our simulation and we've got everything up and running, now we want to start recording data. And we record data using CARLA's sensors. And there are different types of sensors. So there are a number of different types of camera. There's also LiDAR sensors, GPS style sensors, and collision sensors. So we'll start off with the most obvious type of sensor, which is an RGB camera. So we add that by finding the sensor blueprint in the blueprint library, the same as we did for the vehicles. Then another thing we want to do is we want to create an initial translation for the camera. So basically we want the camera to be kind of floating above the vehicle or maybe in front of it, like a real camera on an autonomous vehicle would be positioned. And then we spawn the camera. So basically we use the spawn actor function, and we use this attach to parameter to attach it to the first vehicle that we created, this same one that we have up here. So when I run that code, the CARLA will spawn a camera and attach it to the vehicle, and it's now ready to record data. So we need to now set it off recording data. So we use the camera listen function, and this is the same for every sensor. And we use this lambda expression to start it recording. So I'm going to record into PNG files in this out folder with numbers matching the image frame. So I need to first create that folder to make sure that it's there. And then once I start that, basically the camera will start recording data, and I'll be able to see it appearing in this folder. So here we now have some data. So now if we take a look inside that folder where our output is going, we can see that we have lots of images of the car driving along the road inside the simulation. So now this can serve as training data for our autonomous vehicle. So one thing to bear in mind is that you also need to call camera stop as well. This is important because otherwise the camera will just keep recording and recording data and fill up your hard disk. And that's something that you want to avoid. So that concludes our first introductory tutorial to the CARLA simulator. So now you know how to get the simulator up and running, add some vehicles to the simulation, and then start to record some training data for your autonomous vehicle machine learning stack. So thanks very much for joining us, and keep an eye on carla.org for more tutorials in the future.